Okay, so today we have a problem. Now, let's say you have a rope which you have tied to a bicycle pedal. Here's the rope, and you are pulling it backwards. The rope is being pulled backwards. Now, in which direction the bicycle would go? Now, why is this a tricky problem, or why is this a confusing problem? Because generally, when you are moving your pedals, the pedal actually move in the backward direction. That's the direction in which the pedal moves, and the bicycle moves forward. But in this case, as you are this is bicycle is an object and you are trying to pull it backwards, so it should move backwards. So it's a little confusing. I mean, generally we have seen that when we move our pedals, the bicycle actually moves forward, but in this case common sense tells me that because I'm applying force backwards, so it should move backwards. So what would actually happen? So this is the problem that we'll try to solve today, and we will try to see the maths behind it, and we'll try to see if maths can actually help us and the concepts of physics can help us to answer this. So let's see. Okay, so we will have two approaches to solve this problem. The first approach is that we would do some maths and you'll use the concepts of physics. And using that, we will try to find the direction of acceleration. We have taken the convention that the acceleration in the right direction is positive. So what we will do, we will try to find out the acceleration in terms of various parameters that we have over here, all the constant parameters, and we will try to see if our acceleration is positive or negative. So, in this case, in a case of a bicycle, assuming that A, B, C, D, which are the dimensions over here, can be changed. So if they can be changed, or if even one of them can be changed, ultimately you can come up with an expression that can have both positive and negative values. And we'll try to see what is that expression and if it is even possible to get a positive value or a negative value. So that's going to be our approach one. Our approach two would be to find out the mechanical advantage. We know mechanical advantage is nothing but the ratio of friction and force. Why friction and force? Because mechanical advantage is basically what is the force that gets generated by the system when you apply some force to the system. So if you put some input, what output do you get? In case of bicycle, you put this force and ultimately the bicycle moves because of the friction. So friction is our output while force is our input. So in such a case, friction upon force would be our mechanical advantage. If it becomes greater than 1, then that would mean that friction is larger than force. And if friction is larger than force, then that obviously means that the bicycle is going to move in the forward direction towards the direction of friction. But if friction is smaller than force, and which means if the mechanical advantage is smaller than 1, then in that case, the bicycle is going to move backwards. Okay, so let's see. Here's the diagram which shows all the parameters. You can just check it. We have, just keep in mind that there is tension in the bicycle chain. Okay. And then friction is acting in the forward direction, force is acting in the backward direction. Another thing that we have to consider is that we are not considering the friction in the front wheel, and that is because when you move the pedal, it is the back wheel or it is the rear wheel that responds to the movement of the pedal. And ultimately the front wheel responds, but that response comes once the entire system moves because of what is happening between the front between the sprocket or between the front sprocket and the rear sprocket. So overall, the front wheel is going to move. There is going to be some force acting on the front wheel, but that would happen a moment later. As of now, when we are applying force on the pedal, it is the rear wheel that is going to move, and hence the force that are going to act, any force that is going to act is, or any friction that is going to act, is going to oppose only the movement of the rear wheel. It is only a moment later that since the entire system is going to move in any one direction, it is only then that the front wheel would experience a force. So hence I have not considered friction in the front wheel. Okay, now let's see. Let me just clear this out. Yeah. So here is our approach one. So what we basically have written a few equations, pretty simple. We know that the forces are, as far as translational motion are considered, are friction and force. So force is the external force that we have applied. That is the force that is being applied by the rope. Friction is something that is going to act because the tire is going to move, and hence it is going to move against the surface, and friction minus force would be ma. Now I'm assuming that my that the right hand side over here is the direction, is a positive direction, and hence I have considered friction minus F is equal to ma. If I consider the left side to be positive, then I would then write F minus Fr is equal to ma, and that is like pretty obvious. And then I can write another equation for the front sprocket where force is acting, and if I try to calculate the torque about this point, the center of sprocket, it would be Fc. If I try to calculate the torque due to tension, it would be Tb, because then I would have to consider the radius of the sprocket, which is b. And this should be equal to I alpha, where I1 is the moment of inertia of the front sprocket, and multiplied by alpha. Now alpha can also be written as A upon R, where A is the acceleration of the topmost point, and then if you divide it by R, that makes it angular acceleration. Similarly, I've written the equation for the rear sprocket. Now using these three equations, I have derived a formula for acceleration. Capital A is acceleration, and this comes out to be F CD minus AB, and then you can read the expression. Now if you read this expression, you would see that everything is positive. AB is positive, I2, I1, everything is positive. The only thing that can go negative is CD minus AB. So overall, if you want this expression to be positive, CD has to be greater than AB. Now in a normal bicycle, you can't change anything except D. D is the radius of the rear sprocket. That's the only thing that you can change. So if you want this to be positive, you need a large value of D. And if you have a large value of D, and if that ultimately makes this positive, that means that the bicycle is going to move in forward direction. So for sure, if you want your bicycle to move in the forward direction, you definitely need a very large value of D, or maybe you need a very low gear, right? So we can just plug in the values and we can see if it is happening for us or if it is not happening. For normal bicycles, we have done some testing and we know that no matter how low you go, the D does not become as large so that this CD minus AB becomes positive, and hence the bicycle never moves forward. It actually moves backward. That is for a normal bicycle, but you can definitely get a bicycle designed for yourself where the the rear sprocket actually becomes very large, the gear gets really low, and then you may get a positive value for this. But anyways, now you have an expression. You just want this CD minus AB to be positive if you want your bicycle to move in the forward direction. So we have now maths with us. And in, let's say, if you have the possibility of changing the length of the pedal, if you have the possibility of changing the radius of the front sprocket, then you can experiment with them as well. And this is how the maths would play out, and you can then find out whether it would ultimately give you a positive acceleration or negative acceleration. Secondly, what you can do is you can find out them, as we have already discussed, that you can find the mechanical advantage, which is F upon Fr. Using the same equations, I have found the expression for F, I found the expression for Fr, and then I have figured out the ratio of Fr and F. And then again, you get a relationship which is like this. As you can see in this expression, only thing which is, everything, almost every expression, every single term in the numerator and denominator is same. I2b square, I1dA, everything is same. The only thing that is changing is ABCD and A square B square. So if I want the numerator to be greater than denominator, then ABCD has to be greater than A square B square, right? Because if this is greater, then the numerator is greater, and then ultimately the expression is greater than 1. And that ultimately gives me the same result. CD has to be greater than AB, which is what I was talking about in the last case as well. CD must be greater than AB. So overall, I get the same answer. If CD is greater than B, then friction becomes greater than F, and then it moves in the forward direction. If CD is less than B, then friction becomes less than F, and it moves in backward direction. So this is how mathematically you can see whether the bicycle is going to move forward or backward. Okay, thank you so much. Hope this makes sense.